Okay, I thought that I would do some questions to assist a friend of mine, and she's taking like a intermediate algebra course. So I figured I would start off, and usually, students have issues with word problems, so that's it's a good thing we're starting there, right? So it says you want to make a 10-pound mixture of almonds and peanuts that is worth $4.60 per pound. So the mixture itself is $4.60 per pound. The almonds are worth $5 per pound, and the peanuts are worth $3 per pound. So they want to know how many pounds of almonds and peanuts should you use, right? So this is where it gets a little complicated for most people. You got to make, a set of equations. You got to get variables or letters, really, and you got to figure out how to do that. Now, the hint for what to use for letters, it's shown at the very end of the question. It says, how many pounds of almonds and peanuts should you use? Circling for pounds of something, and it's saying pounds of almonds and pounds of peanuts. So you need two letters. So what I'm going to do is I'm going to call one of them A, right? And guess what? That's the pounds of almonds, right? P is the pounds for peanuts. Sweet. And what it tells us is that if you add the pounds of peanuts and the pounds of almonds, the mixture is supposed to be at most 10 pounds. It's a 10-pound mixture. So you would do A plus P, right? That should be 10. Okay? Now, the mixture, it says it's $4.60 per pound, but it's a 10-pound mixture, right? So the total cost of this mixture will be $46. Okay, now this is the money equation, right? Now, it also says that the almonds themselves cost $5 per pound. So the almond cost on its own is $5 per pound for almonds times the pounds of almonds. Do the same thing added to the peanut cost, and I get my two equations, two unknowns, so I can solve this. And so there are two ways to do this. I'm going to call this equation 1, equation 2. One is like elimination, the other one's substitution. Substitution seems to be the easier way to go for most students. They understand it best, so I'm going to do that. If you're good with elimination, do it that way. So 1 implies that A equals 10 minus P, and notice I'm choosing to isolate for A at first. If you want to choose P, it doesn't matter. Okay, do it that way. So I've got this situation now, and A equals 10 minus P. I can sub that back into here, right? And it's saying multiply it by 5, right? So here's what you do. You go 5, and then don't ever forget the bracket. 10 minus P plus 3P equals 46. And guess what? I've got an equation just with P on its own. So I multiply, they expand the 5 back in, right? And I get 50 minus 5P plus 3P equals 46. Beautiful, right? Now, negative 5 plus 3, right? The 5 has the negative and it's bigger than 3, so I got to get a negative out of this. So it's going to be minus 2P, right? 50 minus 2P has to be equal to 46. Now, I got to solve for P, so like you got to get P equal to some number, right? So I can't have a 50 there, right? So what I'm going to do is, it's a plus 50 right now, so I'm going to take away 50 from both sides. So that will kill those two, and I get negative 2P equals 46 minus 50, that's negative 4. Okay, so that means that P has to be negative 4 over negative 2, and that result is 2. So I've got 2 pounds of peanuts, basically. To get the last bit, A we found, right, in terms of P. Remember that? Oh, gosh. A was found in terms of P, right? I'm going to call this equation 3, okay? So what 3 implies then is that A must be 10 minus 2, because that's P. So 10 minus 2, 8 pounds. And I am done, okay? So that's the first question. Next, I'm going to start a new page. Okay, and let's see. The annual low temperature in, I don't even know how to say it, Nome, Alaska, was recorded as negative 15 degrees Celsius. Now, in Alaska, you're in the States, you're in America, So they deal with Fahrenheit. So you got to write negative 15 degrees Celsius as Fahrenheit using the formula 9/5 of the temperature in Celsius added 32 is the temperature in Fahrenheit. That's all it's saying, right? So it's saying that a temperature in Fahrenheit is just 9 times the temperature in Celsius divided by 5. This is the temperature in Celsius plus 32. That's it. So if they give us negative 15, no problem, right? This guy gets negative 15. Add 32. Okay, so let's see what it is. Negative 15 over 5, right? I can cancel a factor of 5 out of the 15 and I get 3, right? So don't forget that minus. It's a negative 3. Negative 3 times 9 is negative 27 plus 32. So we're looking at about 5 degrees Fahrenheit. Okay, that's what we end up getting. So obviously really cold. Okay, and actually negative 15 degrees Celsius up here in Canada is really stinking cold, right? So that's that. Now we're going to solve some equations, and it has to do with absolute values. Let's do it. So the absolute value of 3x plus 1 minus 5 equals negative 3. Okay. Now, what is the absolute value? So the absolute value of negative 5, right, is 5. The operation basically takes the magnitude, right, avoids the sign is gone, right, and you just take the actual value itself. There's a functional form for it, right? So there's a definition for the absolute value. The absolute value of x, of some value x, is equal to, and it depends on what sign of x you get inside, right? So if you're given like a negative value, right? Oh man, I should put more space here. Okay. So absolute value of x, okay, if the input is negative, so if I punch in a negative number like negative 5, for example, the answer to it is negative x. Now what that does, let me give you an example. So negative 5 is less than 0, right? What it's saying to do is to just tack on a negative in front of that negative 5. That's what this means, right? So that's what you do, and negative and a negative make a positive, so you just pull out the 5. So that's how you do it mathematically. We just know to take the magnitude by rule, right? But that's how you do it mathematically. It's this form, right? Now, what if you punch in something positive? Well, we know by rules we just take out the values, so it's just x. Right? That's the definition. So we're going to have two equations. One where we have this scenario, one we have this scenario. Okay? So let's do the negative scenario because that's a little weirder, right? So what I have to do is if 3x plus 1 is less than 0, I got to put a negative. Minus 5 equals negative 3. The rest doesn't change. What I can do is I can multiply both sides by negative 1 because I see everything as a minus. So it's going to be 3x plus 1 minus, plus 5 equals 3. See how I did that? I just literally multiplied everything by negative 1, which means I change all the signs. And now I remove the brackets because they're useless to me. I don't need them anymore. Okay? Because that negative just went away. So 3x plus 6 equals 3, right? 1 plus 5. So 3x equals, and then I bring the 6 over, right? I subtract 6 from both sides, I get negative 3. So x equals negative 1. That's the first part. Next, it's the more straightforward one, which is just take 3x plus 1. So now we're in the positive regime, right? So whatever's inside, I just place it outside. That's it. And it's minus 5 equals negative 3. This stuff makes negative 4. So you get 3x minus 4 equals negative 3. I add 4 to both sides, right? These guys go away, and I get 1 on the right side, so I get 3x equals 1. So that means that x equals 1 over 4. Oh, excuse me. Wow. 1 over 3, right? Ooh, yeah. Okay, 1 over 3 and negative 1. Those are my two answers. So, and you can double check them. You can check these results, right? So if you plug in a third into here, right, 3x then would be 1. 1 plus 1 is 2. The absolute value of 2 is 2. 2 minus 5 is negative 3. It satisfies. And then the last one is negative 1, so you do negative 1 times 3, that's negative 3, plus 1, negative 2. The absolute value of negative 2 is 2. 2 minus 5 is negative 3. Left side equals right side. We're good. Okay. So, what's up next? Now we have to solve the inequality. Okay? And it also has an absolute value sign. Remember that. So, the inequality, and it says write your answer in interval notation. So, let's do that. So, I think it said 7x minus 3. Okay. I have bad memory for some reason when it comes to that. 7x minus 3. Okay, less than, is that right? Less than 11. Okay. Now, again, there are two situations, right? One where the input itself inside the absolute value is negative, so I got to account for that, all right? And then the other one where it's positive, so I literally just pull it out. So I got to solve for these two separate inequalities. Treat it like an equation. There's only one difference here, right? So I'm going to multiply both sides by negative 1 in this inequality. When you do that with an inequality, this guy has to reverse, right? So I'm going to do that right now. So this is what I should get, right? Because I changed this sign. This thing becomes a positive over here, positive. So I could just take out the brackets. So that's what I have, and I got to change the sign, right? Next, add 3 to both sides, right? So I'm treating it like an equation. And so I end up getting that 7x, right, is greater than negative 11 plus 3. That's negative 8. So x is greater than negative 8 over 7. That's the first part, right? I'm not done. I got to solve for the rest, right? So add 3 to both sides. 11 plus 3 is 14. So 7x is less than 14 then, right? 7x is less than 14. So I end up getting that x is less than 2. Notice I'm dividing by a positive, both sides. So it really, I don't have to change the sign in that case, only when you're dividing by a negative. Okay, remember that. So how would I write this in interval notation? I would do, and notice there's no greater than or equal to sign. It's how would I write this notation of union and sets? So I would do negative 8 over 7, okay, comma, 2, and that would be it. That would be my answer, right? This interval. Okay, next. Let f of x equal to, we're at number 7, let f of x equal to negative 5x plus 2. Okay, fair enough. F of x equals negative 5x plus 2. Okay, what does it want? It wants 4 things. It wants f of 0 first. Now, what it means is, this is an input, right? So x is like something you put in. Multiply it by negative 5 and add 2. It's saying to input 0, right? So if I multiply negative 5 by 0, right, that's 0. And if I add 2, that's 2. Okay, next, f of negative 2. Now I have to input negative 2. So again, negative 2 plus 2. Okay, negative 5 times negative 2 is positive 10, plus 2 is 12. F of x plus 2. Now, this is where students get like really freaked out. The input now is replaced. So it's like 2 terms, right? So if you're multiplying by negative 5, you have to put a bracket. Because that thing multiplies by everything inside the input. The input is this whole thing. So you got to put a bracket, add 2, and let's do this. So now you got to expand. You're going to get a function of x. So it's going to be negative 5x, right? Minus 10 plus 2. Negative 10 plus 2 is negative 8. Okay. And now it's just one step more complicated, right? And here's how it's going to look. Same thing, negative 5 times the whole input plus 2. And I just expanded in the negative 5, and I really can't do anything else to it. That's it. That's my answer. Okay? So, and the reason why I can't do anything else to it is because like before h was like in this previous example, h is replaced by 2, and then I could simplify, but I can't do that now. Whoops. So, number 8. Let f of x equal to this quadratic. Find f of negative 3. Pretty straightforward. So, let's do this. So, this is number 8. Okay. F of x equals negative x squared minus 4x plus 2, I believe. One more check. Negative x squared minus 4x plus 2, plug in negative 3. So now everywhere where I see an input, I plug in negative 3. It's telling me to square the input, right? Multiply by negative 1, take away 4 times that input, and add 2. So always put brackets. You can't fail that way. Okay, that's what I have. The square of negative 3 is 9, so it's minus 9. Negative 4 times negative 3, that's positive 12. Plus 2. This guy's 14. 14 minus 9 is, it is, I don't know why I'm losing myself here, 5. Okay, 14 minus 9 is 5. So that is that. So that is number 8. Number 11, write an equation of the line that passes through the following points. Okay, and there's 3 sets of points there. Actually, really straightforward. So part A, so number 11, okay, write an equation of the line that passes through the following points. These are the 2 points that they want in the first problem, right? 3, 4, and 0, 4. Okay. Notice something. I don't even have to do anything here. Notice something. The y's are the same, right? The y's are identical, right? There's only one way that the y's can be identical, and that's if the line is y equals 4, right? So if it's a horizontal line, that's the only way 2 points with the same y value can lie on the same line. It's got to be that y equals to a constant. So y has to be 4, right? With that in mind, look at B. With B, x is constant. You see that? 2, 1, and 2, 7. The only way you get a line like that is if it's a vertical line at x equal 2, right? That's the only way you get 2 points that have the same x value, is if they lie along a line called x equals 2. That's it. So that's the equation of that line, that's the equation of that line. Now, things are a little more complicated in part C, and I might need to look over it again. So, one more time. So, -1, 3, colon, or semicolon, -4, 5. Okay. So, x1, x2, oh, no, bad. x1, y1, x2, y2. These are ordered pairs, right? So it comes as an x value and a y value, x value and a y value. So I just designated them to be 2 and this guy to be 1. That's it. So this is like 0.1, 0.2. It's very easy to get a line segment, right? So all I need to do is write down the slope equation, right? If it's going to be in form y equals mx plus b, it wants it in slope-intercept form. If it's going to be in that form, I have to use the equation of the slope, and that's m equal to, and m is the slope, right? M equal to y2 minus y1 over x2 minus x1. So I got to find the slope. So the slope will be, let's see, 5 minus 3 over -4 minus -1. This guy on the bottom is -4 plus 1, that's -3. It's going to be 2 over -3, right? Or -2 over 3. So that's what I get there. Next, so I've got my slope, right? I gotta start a new page, sorry guys. So I got my slope, which is negative 2 over 3, and all I need to do is use any one of these points. That's all I have to do. So if I know my slope equation, if I know my line has the form y equals mx plus b, right? I just found m. M is negative 2 over 3, right? So all I need to do is find the y-intercept. And all I need to do is to take a point, right, that has been used in this example, like negative 1 comma 3, right, and use this x value and this y value and sub them in, right? So x is negative 1 and y is 3. So 3 equals negative 2 over 3 times negative 1 plus b. What this means is that b, let's write this equation down. So 3 equals negative 1 times negative 2/3, that's positive 2/3, plus b, right? So I got to isolate for b, so I got to take away 2/3 from both sides, right? So that will kill this stuff, and so 3 minus 2/3 is equal to b. To solve this, I have to remember that 3 can be written as 9/3. So it's going to be 7/3. Okay, so my slope equation is going to be negative 2/3 x plus 7/3. And that's it. I'm done. Okay. Write an equation of the line that passes through the point 1, 5 and is parallel to this line. Now, when it says parallel, right, what it means is it shares the same slope, right? Because when you have two parallel lines, that means that this rise over run, this slope, has to be the same as that slope, right? That's very clear from the diagram, right? It may not be clear just by reading the text, right? So I know that it has to pass through 1, 5, right? So I can use this x and y, right? And also that it has to have the same slope as 3x minus y equals 2. Okay. Now it may not be painfully obvious what the slope is from this form. It's kind of like pseudo standard, pseudo slope intercept form. So I got to put it in the right form. Y equals y on its own mx plus b, right? I got to put it in that form. So here's what I'm going to do. I'm going to add y to both sides, right? Because there can't be a minus in front of y. It's got to be just y, right? So, and then I add y here, and that will kill y's over there. But then I got to take away 2 because y has to be on its own. So I take away 2. So y equals 3x minus 2. So there's my slope. M equals 3. So I do what I did before, right? Y equals 3x plus b, and I got to find what b is using this as my x and this as my y. So 5 equals 3 times 1 plus b. 3 times 1 is 3. So to solve for b, right? So I get 5 equals 3 plus b. So that means if I take away 3 from both sides, right, I get b equals 2. And so my equation is y equals 3x plus 2. Done. All right? So that's that. And let's see. So that's the end of that worksheet, right? So I got to do the other worksheet now. What does it want here? Okay, solve the following system of equations. Oh goodness. Okay, so x plus 2y minus z equals negative 4. Okay. This is going to be a pain, right? So negative 2x plus 4y, I believe. It's going to be a pain in terms of writing down is all. Equals 6. And then you have 2x plus 2y plus 3z equals 1. So let me double check this. X plus 2y minus z equals negative 4. Negative 2x plus 4y minus z equals 6. And 2x plus 2y plus 3z equals 1. Great. Now, there are several ways to solve this problem. The easiest way to do it is using matrices, and it's kind of like a little game, really, is what I like to call it. What you have to do is the following. You have to make a box of numbers. So you put, instead of x, you put 1. Instead of z, you put 1, 1, right? You got to replace that. And then you draw this box, right? So let's do this. And it's going to be 3 rows and 4 columns. So watch this. So it's going to be 1, 2, negative 1. And then to represent the equal signs, I'm going to draw a big line. And that is going to be negative 4 on the left. We've got negative 2, 4, negative 1, 6. Here I'm going to have 2, 2, 3, 1. Okay, what I'm going to do, right, to save space, I will literally just erase numbers and work the math myself. What I want you to do is, as I'm doing step by step, I want you to draw a new matrix that represents new rows. So like if I change a row, I want you to draw a full matrix with the row changed and the rest the same. Okay, so notice that here I have a 1, right? What I can do is if I take 2 times the first row and add that to the second row, that will kill off this 2. That's my goal. That's what I want to do. Okay? So I'm going to double this value and I get 2. 2 plus negative 2 is 0, so that will kill this guy. This is where you start with a new matrix. 2 times 2 is 4 plus 4, right, is 0, is 8. 2 times negative 1, okay, is negative 2 plus negative 1, that's 2 times negative 1 is negative 2 plus negative 1 is negative 3. 2 times negative 4 is negative 8 plus 6 is negative 2. Okay. Now notice again I have the 1 here, and I can use that 1 to kill off this 2. Okay, so what I do is I do negative 2 times row 1 and add that to row 3. Okay, negative 2 times 1 plus 2 is 0. Negative 2 times 2, that's negative 4, plus 2 is negative 2. So you know what, I'll just do this. Okay, negative 2 times negative 1 is 2, added to 3 is 5. Negative 2 times negative 4 is 8, plus 1 is 9. Okay. Now to make things easy, notice I have a 2 over here, right? And I have a negative 2 over here. So what I'm going to do is I'm going to add row 3 to row 1 to produce a new row 1 and kill off this 2, right? So if I do that, let's try that. So negative 2 plus 2, that is 0. 5 plus negative 1, that's 5 minus 1, that's 4. I'm literally just adding, right? 9 plus negative 4, that's 5. Okay, and that's the final result there. Next, what I want to do is I want to divide the second row by 8. So what I want to do is I want to essentially convert this middle term to a 1, right? That's my goal. So then I can use that 1 to kill this guy, right? So here we go. So 8 divided by 8 is 1. Okay. It's going to be negative 3 over 8. Over 8. and it's going to be negative 2 over 8. Negative 2 over 8 is negative 1 over 4. Okay. Now what I'm going to do is I'm going to multiply row 2 to row, I'm going to multiply row 2 by 2 and add that to row 3 to kill this guy off. Okay, so let's do that. So I get 2 minus 2, that's 0. And it's going to be negative 6 over 8 because I multiplied it by positive 2. Right, so I multiplied 3 over 8 by positive 2. So I get negative 6 over 8 added to 5. Now I have to change this guy as a fraction over 5. That's 40 over 5. Right? 8 is 40, 40 over 8. So 40 over 8 is 5. So I put it in terms of a fraction, and what I end up getting is 34 over 8. So 34 over 8 can be reduced to 17 over 4, right? So this number right here will be 17 over 4, okay? So it's all just a little game, right? That's all I'm playing here. So now I have to multiply this guy by 2 and add that to 9, right? So negative 2 over 4, right, plus 9, but negative 2 over 4 is just really negative 1/2, right? Added to 9. 9 can be written as 18 over 2, so I get 17 over 2. Okay, now notice 17 is common, right? You have 17 in the bottom row, right? So what I'm going to do is I'm going to divide row 3 by 17, right? So the 17 is going to be replaced by 1. Then I'm going to multiply the entire row 3 by 4. So what I end up getting is 1 over here, 2 over here. Great. So what I just did was I found that my z value, see how there's nothing else here, nothing there. What I found was that z equals this number. So z equals 2. Okay? Notice the top equation, what it's actually saying is that x plus 4z equals 5. This is the x coefficient, this is the z coefficient, this is the answer, the equal sign on the opposite side. So if z equals 2, right, that means that x plus 4 times 2 equals 5. So x plus 8 equals 5. That means that x has to be negative 3, right? If you manipulate, right? X has to be negative 3. So I just found x and I just found z. All I have to do now is find y, and that's it, right? So I'm going to use my second equation, right, which says that y minus 3/8 of z equals negative 1 over 4. But again, z is 2. Z is 2, right? So plug in 2. The 2 will cancel with a factor of 2 in the bottom, so I get negative 3/4, right? So I get y minus 3/4 equals to negative 1/4. So add 3/4 to both sides, right? What will happen is these 3/4 will cancel, and I get y equals to 2 over 4, which amounts to 1/2. So y equals to 1/2. So I get y equals to 1/2, okay, x equals negative 3, and z equals 2, and that's my solution set. Okay, let's try it just in case. I'm going to plug everything back to see if it works, right? So negative 3 plus 2 times 1/2 minus 1 times 2 should be negative 4. Let's try it. So negative 3 plus 1 minus 2 is negative 5 plus 1, negative 4. First equation is good. Okay, so that was the first check, right? So far it is so good. So that's the first equation. Really quick. Negative 2 times negative 3 plus 4 times 1/2 minus z, which is, what the heck was z? 2, right? So it's going to be 6 plus 2 minus 2. So 2 minus 2 will cancel, so I get 6 left. So that's good. So far so good, right? Both equations are satisfied right now. So the third one is probably satisfied, but heck, I'm going to check just in case. 2 times negative 3 plus 2 times a half plus 3 times 2. So this is negative 6 plus 1 plus 6. So I get 1, right? Because the 6's will cancel. So there you go. So that's that guy. That's the solving linear systems of equations, right? Using matrices. Just a note on that, you could easily have just like manipulated the equations for x and y and plugged in, but that would have taken a lot of paperwork. So I just did it in terms of a little game that I like to play with matrices and stuff that I learned in linear algebra. Okay, so graph the following system of linear inequalities. So, okay, here's how you do this. 3x plus 2y less than or equal to 4. This sort of takes me back to linear programming. Okay, so here's what I have to do. I have to draw my quadrants, right? Y and x. Okay, whoa, this is going to look really confusing. What I want to do, right, is I'm going to take this first inequality. I'm going to call it an equation, okay? And I'm going to have to draw this. So to draw this line, right, because this is basically an equation of a line, right? To draw this line, set x equal to 0, right? If x equals 0 there, I'm going to get 2y equals 4. So y will equal 2. So what I just found, when I set x equal to 0, I just found the y-intercept. So that guy is going to intercept at 1, 2, right there, okay? Next, I do the same thing for the y-intercept. So I set x equal to 0. I set y equal to 0, right? And I find the x value. So 3x will equal to 4, and so x will be 4 over 3. So 1, 2, 3. Okay, let's say that is, how am I going to do this? Let's say each of this is like a third of a unit, 2/3, 3/3, 4/3, okay? So that this is 1, right? Then that's my x-intercept, and I've got a line. Now these are both points on the line, right? So I have to connect them. Now also the condition is that y has to be greater than 1, right? 1 is right there because that's 2, right? So essentially my solution set, right, is everything below, right? Because remember this was less than or equal to 4. So everything below that line but above this line, right? So what I do is I shade it all in, right? And that is my set of solutions that satisfy these two inequalities at the same time. So it's essentially a geographical region, right, of points. So that's my answer. It's this little shaded region, okay? Next, simplify. Oh gosh, I did it yet again. I don't know why I'm screwing up with that. Okay. Simplify, write your answer using positive exponents. Okay, we can do that. Let's see, simplify using positive exponents. So this is going to be hard to write. 6a cubed b squared, I think, all to the -1. Is that right? No, -2 over there. Right, good. Okay, and 2a to the -2 b all to the power of -2, right? Okay, I just have to keep checking just in case I screwed up bad. Okay, then multiplied by 3a b cubed over 2a squared b to the negative 3 all squared. Okay. All right. Now what these negatives do, right, is they tell me that I can flip them, right? So I can bring this whole term down and switch that sign to a positive 1, right? That's one way to do it. And there's another way to do it where I just literally distribute that negative 1 to each exponent, right? So here's what I'm doing. I'm just going to flip everything, right? So what I have there, 6a cubed b to the negative 2, right, will just go to the bottom and we'll take on an exponent of 1. Now when you take on an exponent of 1, you basically don't have to write anything, right? Exponent, like 2 to the 1 is 2, for example. 3 to the 1 is 3. So I just have to write that. And then this guy ends up on the top because that also has a minus, so you flip it, essentially. But now you got to put an exponent of 2 instead of negative 2. Okay. So what I'm going to do is I'm going to distribute the square into everything, right? So 2 squared is 4, right? A to the negative 2. Negative 2 times 2 is negative 4, so I get a to the negative 4. Here I already have an exponent of 1, so 1 times 2 is 2. That's how you distribute exponents in that sense. You have to multiply them. And I get 6a cubed b to the negative 2, right? Here I can actually work it out a little bit. Let's see. When I've got powers like this, right, which is found right here, what I can do is I can take the base and subtract the exponents like that. So I get a to the negative 1, right? So right now that a ratio gets compressed as a to the negative 1. Okay, I do the same thing for b. So for the b, it's going to be 3 minus negative 3. And I get b to the 3 plus 3, and I get b to the 6. So I get b to the 6. Okay. Now I do that sort of ratio stuff over here as well. 4 over 6 is 2/3, right? So I do a to the negative 4 minus 3, right? Negative 4 minus 3 is 7. Negative 7, excuse me. This is going to be b to the 2 minus negative 2, right? And that's just b to the 2 plus 2, which is 4, right? Now, what that square does is it distributes to everything, right? So this is going to be 9 over 4, okay? And this is going to be a to the negative 2, b to the 12. Okay. Now notice there are b's, there are a's, and there are numbers, right? Like 9 over 4 and 2/3. So I can simplify this, right? And here's what I have to do. I'm going to start with the fractions. The factor of 3 on the bottom will kill with a factor of 3 on the top, and I get 3 left over. A factor of 2 on the top will cancel with a factor of 2 on the bottom. So what's left is 3 over 2. That's it. So I get 3 over 2 as a coefficient. Then when I'm multiplying exponents, when I'm multiplying powers, I add the exponents. So I got negative 7 plus negative 2, right? Negative 7 minus 2 is negative 9. For b, right, I get 4 plus 12, right? So that is 16. Now, it says the answer has to have positive exponents. Now, obviously, the a doesn't have a positive exponent, but no problem. All I have to do is put the a term on the bottom, and now it will get a positive exponent, and that is my answer. Okay, so I hope everything was good over here. I just got to check the work. Always check your work, guys. Yeah, it seems legit. It seems legit. 9 over 4, yes. Yep. And that's 2/3, so cancel, cancel. Okay, and then you get -9 and 16, and that seems good. Okay, so we're good. I was just checking that just because it was a really long question. Next, it tells you that f of x, okay, some function of x, is equal to 6p plus q times 5p minus 2q. And that g of x equals p plus 3q squared. Okay. And it wants you to find this kind of pseudo function where you subtract g from f and you get some new function h, right? So I need a new operation h that is essentially a subtraction of f and g. So let us expand here. So we get 30p squared minus 12pq plus 5pq. So -12 plus 5 is -7 pq minus 2q squared. Okay, this guy is going to be p squared plus 6pq plus 9q squared. Okay, so f minus g must be 30p squared minus 7pq minus 2q squared. That's f minus, remember I'm putting brackets, brackets are important, p squared plus 6pq plus 9q squared. Okay, 30p squared minus 1p squared, right? Actually, let me just expand. 30p squared minus 7pq minus 2q squared minus p squared minus 6pq minus 9q squared. Okay. 30p squared minus p squared is 29p squared. Minus 7pq minus 6pq is -13pq. Minus 2q squared minus 9q squared is minus 11q squared. And so that's what I get for f minus g of x. It doesn't look like you can really factor any further because you get prime numbers, like 29 is a prime number, 13 is, so is 11. So it seems like that is your finale. That's your final result. A little weird. I've never seen a question like this before, so if I do make a mistake, I apologize. Divide using synthetic division. Okay, I actually don't know how to do synthetic division. I've always resorted to doing long division, so I'm going to do long division for this question. There is an easy way to do synthetic division. I could easily look it up. I'm sure it's not too bad. Why don't I try looking it up then? So let's see, synthetic division. I never really use long division, to be honest with you. Let's see. So you put 1, 5, and 6 the components, and you put the 1 there, the test 0 at the left. Then you multiply. No, carry it unchanged. Then multiply, and that goes over. Add down the column 6, and then multiply again. Okay, so it doesn't look too bad. and the last carry down value is the remainder. Okay, okay. Sounds good. So let's do it then. Let's do long division, or synthetic division. So 3x to the 4, okay, minus 5x cubed minus 21x squared, right? 21x squared plus 17x plus 25. It has to be divided by x minus 3. So the test 0 is basically the value that makes the bottom 0. X has to be 3. So the test value is 3, right? So here's what I do. I line them up. So I go 3, negative 5. I'm taking the coefficients in front of my variables, right? So this guy, this guy, this guy, this guy, and this guy. So negative 5, negative 21, 17, 25. This is my first go at synthetic division, believe it or not. Okay. So I carry down the 3, right? I think I leave it inside the box. Is that right? No, it goes right here, 3. Multiply 3 by 3, I get 9. That goes over here. Add down the column, negative 5 plus 9 is 4. Then I multiply through. So 3, now this 3, multiplied by 4 is 12. Add down the column, I get negative 9. Right? Negative 21 plus 12. Then I multiply 3 by that, so I get negative 27. Then I add down the column, I get negative 10. Multiply through, and I get negative 30. Add down the column, I get negative 5, right? So my my result, right? My result is this guy, right, with this remainder, right? So all I have to do is put in variables, right? So I started with x to the 4, so this is probably going to have x to the 3. So it's going to be x to the 3, 3x to the 3 plus 4x squared minus 9x minus 10. That's my result, with a remainder equal to negative 5. Okay? This is called the dividend, right? This is dividend. Okay? This is the remainder. No, sorry. This is not the dividend. This is the quotient. Quotient. I apologize for that. This is the quotient. This is the result of the division, right? This is the dividend. And this is the divisor. Yeah. So that's what I get for my result for the synthetic division. Factor completely. Okay. So factor completely. 16x cubed plus 4x squared minus 6x. 16x cubed plus 4x squared minus 6x. Okay. Now, there's a common factor, right? Common factor is, it won't be 4, it'd be 2, right? Because I can't divide that by 4. So it's going to be 2x, and what I end up with is 8x squared plus 2x minus 3. Okay? Now, I need two numbers to multiply to negative 24, but add to positive 2. That is going to be positive 6 and minus 4. So I got to split the middle term. So why don't I do this? Okay. I'm going to introduce another set of brackets. And out of this guy, I can factor out 2x. And what I end up getting is 4x. No, I end up getting... No, I can factor out 4. What am I doing? I can factor out 4x, right? So I end up getting 2x minus 1, right? Out of this guy, I can factor out 3, and I end up getting 2x minus 1. Okay? So I've got a common factor, right, over here and over here. So I can take out 2x minus 1, and what I'm left with is 4x plus 3. And that is my final fully factored form. Okay, next. Took a lot longer than I thought. Factor completely. 16x to the 4 minus 81y to the 4. 16x to the 4 minus 81y to the 4. Now, this is a difference of squares. Okay, so you've got the difference of squares formula, which is a squared minus b squared equals a minus b times a plus b. Okay. Here's how I can write it as a difference of squares. Watch this. The square root of 16 is 4. The square root of x to the 4 is x squared, right? Meaning if I squared x to the x squared, if I squared x squared, I would get x to the 4. So that first term can be written like that. And then this guy can similarly be written like this. Okay? So using my formula, right, this is a, this is b, and so my brackets would be 4x squared minus 9y squared, okay, times 4x squared plus 9y squared. We're not done. Okay, so this is also a difference of squares, and it can be rewritten like this. 2x squared minus 3y squared, okay. And this guy, I think they have complex numbers in this course, right? So they have imaginary numbers. If they don't, you don't have to break this down, right? But if they do, you do have to break it down. So we'll do that right now. So assuming that they do have imaginary numbers or complex numbers in this course, I'm going to break down both of them. This can be rewritten as, again, the difference of squares. So it's going to be 2x minus 3y, right? This is the new a. This is the new b. A minus b times a plus b. Okay, so that covers this thing, right? Now what about this? I can rewrite it as 2x minus I 3y, okay, times 2x plus I 3y. The reason why I do this is because that I and that I will multiply together. And what you'll end up getting is you'll get minus I squared, and that's going to be positive 1, and so you'll end up getting this back, right? I want you to try that, okay? So that's what I get for the fully factored form for this equation if there's complex imaginary numbers. If not, then it's this with this, okay? So this is for real numbers, this is for real and imaginary, okay? Next, solve for x. X times 5x minus 2 equals 3. X times 5x minus 2 equals 3. X times 5x minus 2 equals 3. Not a problem. Very easy. I have to expand the x first, right? So it's going to be 5x squared, okay, minus 2x equals 3. Subtract 3 from both sides, right? And I end up getting 0 over here, and a minus 3 on the left side, right? Now, I need to see if this is factorable, right? So I'm going to put a set of factors. 5 is a prime number, right? So you know that the factors have to have, one of them has to have 5x, the other one has to have x. 3 is also a prime number. So one of them has to have a 3, and the other one has to have a 1. But I don't know if this orientation is good, right? Watch this. So 5x times 3, that's 15x. Already there's no way I can get negative 2 in the middle. So I switch the 3 and the 1. 5x and a 3. I can get negative 2 provided I do this. Negative, positive. Because it'll be negative 5x plus 3x. That'll give me negative 2x. So I can solve this guy. This guy will tell me that x equals 1. This guy will tell me that x equals negative 3 over 5. Work it out and you should get that. Those are your two answers. Next. I think this is the last question. State the domain of the rational expression. Well, the only problems really that I see with this is that you can't divide by 0, right? That's the one thing you cannot do, right? That is taboo. So you've got p squared minus 4 divided by 2p squared plus p minus 10, right? So this can't be 0, right? 2p squared plus p minus 10 cannot be 0. I need to know what this factors into first, right? So I'm going to factor it. 2p, right? 2 is a prime number. This is a prime number, so I could do that same trick before, the guess and check. I need a negative 10. How can I get negative 10? I can get negative 10 with like 5 and 2 or 10 and 1. But if I use 10 and 1, I'm probably not going to get the plus 1 in the middle. So what I'm going to do is essentially I'm going to do 5 and 2. So I'm going to give the 2 over here and 5 over here because the 2 will multiply with 2 and I'll get 4 and I get 5 here. To get plus 1, this has a plus, this has a minus. Okay. So that means that there's no way that p can be 2 and there's no way that p can be negative 5 over 2. So these are both not allowed. So the domain would be x belonging to real numbers such that, or really p, right? P belonging to real numbers such that p does not equal to negative 5 halves or 2. Okay? And that is it. That's my domain. Thank you so much for watching. I hope this was of help to you. This was a long set of exercises. Please support us. Please like, subscribe, comment, and share this video. And I sincerely hope this was of help to you. And have a good one. Good luck on your exams. You guys are going to do great. Great. Have a good one. Bye.